For B2, we have an interesting problem because we have a singularity within this definite integral or in the domain of integration. So we need to split it up into two integrals. It's equal to the integral from -1 to 0 of 1 over x to the 1/3 with respect to x, plus the integral from 0 to 1 over x to the 1/3 with respect to x. Now, here, this split only works if each of these are defined or they give us a definite form. But if they don't give us a definite form, we can't solve it. This is why we couldn't solve the integral from -1 to 1 of 1 over x dx. It gives us issues. So we're really just hoping and praying here. But now we can set up an improper integral for both of these expressions. So it's the limit as b approaches 0 from the negative of the integral from -1 to b of x to the -1/3 dx, plus the limit as a approaches 0 from the positive of the integral from a to 1 of x to the -1/3 dx. The reason why I changed the expression for the power is to make the power rule easier. So this equals the limit as b approaches 0 from the negative of x to the 2/3 over 2/3, evaluated at x equals -1 to b, plus the limit as a approaches 0 from the positive of x to the 1/3 or x to the 2/3 over 2/3, evaluated at x equals a to 1, which equals the limit as b approaches 0 from the negative of 3 over 2 b to the 2/3 minus -1 to the 2/3 3 over 2 times that expression, plus the limit as a approaches 0 from the positive of 1 of 3 over 2 times 1 to the 2/3 minus 3 over 2 a to the 2/3, which equals now b approaching 0, so this is 3 over 2, 0 to the 2/3 minus -1 squared is 1, cubed root is 1, so minus 3 over 2, plus 3 over 2 times 1 to the 2/3, which is 1, minus 3 over 2 times 0 to the 2/3. And this gives us 0 minus 3 over 2 plus 3 over 2 minus 0, which equals 0. So our definite integral is 0. Now for B2, we have two integration questions. One is a integration question using the fundamental theorem of calculus 1. So here, in order to do this fundamental theorem of calculus 1, we need to split this up into two integrals. So this is the derivative with respect to t of the integral 3t to a of secant x dx plus the integral of a to e to the t secant x dx, which equals d by dt of the integral from a to e to the t secant x minus the derivative with respect to t of the integral from a to 3t secant x dx. And using our chain rule, this is equal to secant e to the t times the derivative of e to the t with respect to t minus secant 3t times the derivative with respect to t of 3t. So this equals secant e to the t minus secant 3t times 3. And this is our solution. In the second question, we have something that's tempting to use a u sub, but we don't need to. We can simply distribute. So this equals the integral of x cubed plus x squared dx, which equals x to the 4 over 4 plus x to the 3 over 3 plus c. And we have our solution. B3 is our dead body problem. So with our dead body problem, we have a body found and a body in morgue. And these bodies follow Newton's law of cooling, which have a original time, T of t, T naught, T surrounding, K, and time. T of t, T naught, T surrounding, K, and T. Now, the dead body found in the woods at 3 a.m. We'll come back to that with a temperature of 17 degrees. The surrounding temperature was 12 degrees. The body is then transported to the morgue. At the morgue, the body's temperature is measured to be 19 degrees. The original temperature is 19, so it actually goes up, but that's fine. 3 hours later, time equals 3. The body's measured to be 9 degrees. Given the morgue's temperature, the ambient temperature is 4 degrees. Approximate the time of death, assuming the initial temperature is 37 degrees at death. We need to know our Newton's law of cooling, and the Newton's law of cooling is T equals T surrounding plus T naught minus T surrounding e to the k t for both expressions. Now, again, you could have minus kt or kt. It doesn't matter as long as the two expressions match. You will see Newton's law of cooling or heating expressed in both ways. So here, we're able to solve for k in the morgue and use that to solve for the time taken for the body to be found. So 9 equals 4 plus 19 minus 4 e to the k 3, because it was 3 hours later. So 9 minus 4 equals, this is a 4, so 15 e to the k times 3. So 5 over 15 equals e to the k times 3. So 1 over 3 equals e to the k times 3. Ln of 1/3 equals 3k. K equals ln of 1/3 over 3. I have ln of 1/3 over 3. Now we solve for our time. So here we're given that T of t is 17 equals 12 plus 37 minus 12 e to the ln 1/3 divided by 3t. So 17 minus 12 equals 37 minus 12 is 25. E to the ln of 1 over 3 divided by 3t. So 5 equals 25, or 5 over 25 equals e to the ln of 1 over 3 divided by 3t. So ln of 1/5 equals ln of 1/3 over 3t. So t equals 3 ln of 1/5 divided by ln of 1/3. Here, our time of death, so that's the time it's been dead. So the time of death equals 3 minus 3 ln of 1/5 divided by ln of 1/3 hours. And if I were to ask this on an exam, I would provide a hint. And the hint would be what this expression equals. And then you'd use that hint to solve the final answer.